Okay, let's continue. So have any one of you tried to attempt this tutorial question? No? Okay, so this one, it asks you to calculate the amount of water in gram that can be vaporized to a boiling point with 155 kilojoule heat. So basically, you're given the delta H, you convert back to gram, right? So if you look at the chart, the table, right? The table gives you boiling point. You take a boiling point, a certain kilojoule per mole. You take this one divided by the number, you get mole, then multiply by the water molecular weight. Understand, right? The concept of solving that, all right? Okay, so let's continue. Okay, the answer for this one will be 68.6 gram. Yeah? Okay, this one, another one. Okay, now we go into 3.5, melting, freezing, and sublimation. Yeah? This section, you should be able to explain the process of melting, freezing, and sublimation. You need to use the delta H in your calculation. So we back to the principle of thermal energy. So if we give more thermal energy, it will start to vibrate. Then it will break the bond and change the state. So at melting point, it receives enough thermal energy to break the thermal molecular forces that is change the state from solid into liquid. Yeah. So we need to understand how we use the keyword intermolecular forces, how we use the thermal energy, and link to the state of that particular substance. Okay, so just want to point out, for melting point, it's a point or condition when you have enough energy to overcome the intermolecular forces. So these are the thing. So you might be asked to predict or draw the graph for the behavior of a certain substance. So you'll be given a certain substance started heated at a certain temperature. So in this case, started heated at 253 Kelvin. Then it will say the substance start to melt at a certain temperature and change into liquid and start boiling at a certain temperature. Right? You should be able to draw this line based on the statement of the questionnaire. All right. So in here, the temperature before the horizontal line will be state of solid. On the left hand side of the line, the red line will be solid state. However, the temperature is increasing, then it will need more heat, the delta H, to melt the substance. It will remain as solid. Once it starts melting, turn into liquid, then you will see the rise of temperature. Okay. So just a understanding on the melting point. Once the melting point of a solid, the state here is solid, is reached, what will happen to the temperature if additional heating is given? So will the temperature continue to increase or maintain? What will happen to the temperature? your state of substance now is solid. Once the melting point of the solid is reached, if you continue to give energy, what will happen to the temperature? Will increase? This point. Yeah, this point. The temperature will maintain, right? Okay. So the temperature will maintain. What it changes is the rate of melting will change. Temperature will not change. Temperature will maintain until all the solid is melt, 100% is melt, then temperature will increase. Yeah, you have to understand the state of the substance. Okay. When you start from solid and you start melting, you keep adding energy, the temperature will not increase, but it start melting. Right? Because the energy was used to break the intermolecular force. It do not increase the temperature. Okay, now it do not raise the temperature above the melting point, but it will start to have more and more melting happen. The rate will be happen. Okay. So what will happen to the condition is that it will hold at 273 Kelvin with a mixture of water and ice until all the solid ice converted to water. Then it will start to convert into gases. Right? So at what point the temperature will rise? You need to know the stage where all the ice have been melted or all the solid state of that substance have been converted into liquid. In this case, we use water as an example. The keyword here is the state of that substance. Yeah? So your answer should be after all the solid state have been changed to liquid, then only the temperature will be increased. Okay, so this is the most common thing that you do in your daily life. We cool a drink by dropping a few ice cube inside there. As the ice melt, the drink cools because the melting is endo or exo. Endo is what? Endo is receive. Exo is give away. So this one is exo or endo. Endo, why? Why? Why is endo? If it's exo, why? Why exo? Okay, think a bit. He do not ask you about the drinks. He asks you about the ice. What happened to the ice? The melting process. I mean, the melting process is you melt something is you give energy or you receive energy. Let's say steel. Let's say I take steel metal. Metal melt into molten steel. The process is endo or exo. Okay. How you melt something? You need to receive heat. Receive heat is endo. Yeah. You melt the thing is endothermic because you receive heat, you receive energy. Opposite of melting It's exo. Means if you're breaking an intermolecular force, you're breaking the intermolecular force, you change from solid into liquid, you need to receive heat to break the intermolecular force. You receive energy is endo. And you from liquid to ice cube, liquid to solid, you need to less vibrate, right? The molecule need to less vibrate. How you less vibrate? You give energy. You give out energy. Okay. So this is the reverse lah. This is the reverse. So this one you read now. Okay. Okay. Freezing is exo, right? It's exo because heat is released. It's just opposite concept from the previous slides. Again, we highlight endothermic and exothermic. Endothermic and exothermic. Endo, you receive energy. The delta H is positive. If it's exo, you give away, you minus delta H. Okay. The rest you read. Okay, water is a special substance. When it begins to freeze, it will start to give energy. So in the fridge, in your fridge, there is a heat converter. It pull out all the heat from the liquid or from the substance. So there's a heat sink behind the refrigeration system, like aircon. You actually take away the heat. Okay, this one you read lah. This one you read. Nothing important. It's not nothing important, but the concept you already learned in your SPM level. Okay, this is a bit interesting. You can build your own ice blended soda water by putting your Coke or other soda drinks in the cube for 2 hours without shaking it or without moving it. Then you pour it out. It will form ice cubes. So you can take the water, put in the fridge without doing anything, leave for 2 hours. This have to be clean water. Then you pour it out. You need ice cube to let it form. So if you go to Thailand, for example, they sell you Coke ice. It's a shaker. Then you pour it, then you so you can see the same water. When you put the ice above it, it will crystallize. And if it's cool enough, it will break the glass because it's expensive. Glass is not strong enough, then you will break. Okay, just now we see vaporization, delta H VAP. Now it's another scientific parameter. It's called delta H fusion. Delta H fusion is to melt something. Melt something in 1 mole amount. You want to melt 1 mole of solid, is called fusion, heat of fusion. You convert solid, 1 mole of solid is called heat of fusion. This now is vaporization, is 1 mole of liquid. If you go back to the previous slides, that give you delta, this one. Heat of vaporization, delta H VAP is liquid. 1 mole of liquid. If it's fusion, it's solid. Yeah. Okay, so the same thing. If you talk about solid, if you pay attention to the equation just now, the bracket just now is liquid to gas. Just now, the delta fusion just now. Right, something. Just now, delta H vaporization is something in liquid to gas. If it's fusion, it is from solid to liquid. Bracket is a state, so be careful from the stoichiometric equation. Right. So if you see S bracket S to L, although you do not write anything below the delta H, we know that if you convert S solid into liquid, that is a fusion heat. Okay. So again, positive is receive, is positive. Negative, positive is endo. Negative is exothermic. Okay. So you should be able to write the same equation. If the question asks you to write an exothermic chemical reaction. So how to write exothermic reaction by using this as a reference? For example, how you freeze a water. How you freeze a water? You write H2O bracket liquid on the left hand side, arrow, then put the S on the right hand side. Delta H is negative. Same magnitude, negative 6.02 kilojoule per mole, but it's negative when you convert liquid into solid. And this is an exothermic. Yeah. So you can see this is another example. If you understand the top one, you should be able to understand the below one. Again, we keep repeating endothermic, keep repeating exothermic, we keep repeating intermolecular force, thermal energy. Yeah, these few things. So again, you will see a new table. It's called heat of fusion. You'll see something like this. You see melting point, you see heat of fusion. During exam, you will see a more complex table that you will see in the form of encyclopedia, where I write something on whiteboard. This is the element. You will see a loss of parameter in column. You will see delta H, vapor, delta H. You will see vapor at 25 degrees C, boiling point, V vaporization, delta H fusion. You see delta F and so on. So you'll see a long list of table in test or final exam. You won't see something like this. Huh? So at least you understand what is heat of fusion. Okay. Heat of fusion is to melt something, to melt solid into liquid. This is another example. So again, you have two columns. One is at boiling point, one is at 25 degrees. So just give you comparison between fusion and vaporization. There's a difference. Yeah? There's a difference between two. Same unit, kilojoule per mole. Same unit. Okay. All right. So if you compare water, table on the top is fusion. Fusion is melting. You convert solid into liquid. Bottom table is vaporization. You convert liquid into gas. So you can see the heat is a bit different. Heat of fusion is less, only 6 kilojoule. But if you see boiling point, it's 40 something kilojoule. Yeah. So fusion, heat of fusion is significantly lower than the vaporization. Okay. So again, you need to answer why. Why both 1 mole of water, one you only need 6 kilojoule, one you need 40 kilojoule. Why? You need to look at the state law. One is from vaporization, is from liquid into gas. One is from liquid into solid. Again, back to the diagram that you see in this morning. We see how we define the state of substance. We define by the distance of the molecule. And what? There are a few things, distance of molecule and then energy, right? There are three factors, right? Since the first chapter 3 slides. Which one is nearer? When you convert liquid into solid, the molecule already very near. You want to push them together, so you need less energy to push them together. So you need less heat, means energy to pull them together. However, from liquid into gas, you need to kick somebody out from the house. You need more energy, right? So again, we explain based on the intermolecular force, and also the distance. So vaporization require complete, the word is complete separation of one molecule to another one. So you must overcome the intermolecular force. You're breaking the intermolecular force, completely separation. Right? However, melting, you only need to handle partially overcome the intermolecular. You do not break the bonding, the forces, right? So the key word here is intermolecular forces. Again, so it explains why the heat of fusion for water is only 6, but the vaporization for water is 40 something. It's because you need to handle the intermolecular forces. Vaporization, you need to completely separate the molecule. However, for melting, you don't need to care so much because you only need to overcome a little bit for the intermolecular forces. You push them together. All right. Okay. Again, when we use the heat of fusion, is to calculate the amount of heat energy required to melt a certain amount of solid. Just now, the V vaporization is liquid, but if you see the question asks you to convert heat of fusion, means you convert solid into liquid. You melt something, you melt something. Okay, so again, you need to find the number of moles for the solid. How you know it's solid? In the equation, you see the bracket. If the bracket is S, it's a solid. If the bracket is L, it's liquid. If the bracket is, sometimes you see AQ, aqueous, it's also liquid. If it's sometimes you see bracket gas, I mean gas bracket G is gas. Okay, so if you understand, you should be able to do this question. Calculate the amount of heat required to melt 25 kilogram of ice at 273 Kelvin. So this one refer to table just now. So 1 mole of ice, so this one amount of heat here, because it did not mention what kind of heat, it just tests you whether you're able to differentiate between vaporization and fusion. So here it asks you the word melt. Melt actually converts solid into liquid. So you see the table, ice is a water, H2O. How many kilojoule per mole? Fusion in table, how many kilojoule? 6 point something, Okay, water, 6 point something. So 1 mole, you should able to find is 18.02 gram for 1 mole. Here in this table is calculated by 1 mole per mole. So water is 6.02. Water won't come out in the test anymore. So what if I change the question into one of these 3 you should able to do? This one will link to chapter 8. Okay. Okay. 25 gram, you should able to calculate in mole. 25 gram equal to how many mole? Divide by 18.02. Take this number, 25.0, divided by 18.02 to find number of mole. Once you get the mole, refer to table, multiply the mole with this value, you get the heat you require to melt. Yeah. Okay, I'll let you do the substitution, and the answer for this one is 8.35 kilojoule. Again, I marked the wrong, I canceled the wrong things. The blue slash here should be on the gram and not H2O. So for if this question come out, remember to give me a more structured answers. For example, this one, don't write like what you see on the slide here. You need to tell me what actually you are trying to do in your answer. For example, the first one, you should able to do number mole of H2O equal 25.0 gram multiply, or you can straight away divide, right? 1 over 18.02 gram. This is mole H2O. H2O. You should write like this, Then you do how many mole? This. So the first line is like this. You write number mole of H2O equal 25.0 gram multiply 1 mole or over H2O divided by 18.02 gram, or you can write like this, 25.0 gram divided by 18.02 gram per mole. Yeah, this. Either this way, these two ways. Okay, equal to how many mole? Equal to 1.387 mole. Then do another one. 1.387 mole of H2O equal 1.387 mole multiplied by 6.02 kilojoule over mole. Then you write kilojoule. Okay, you need to tell me what actually you are trying to do in your mathematics steps. Don't write something like on the slides here. On the slide here, I just show you the calculation. In your test, you need to tell me what actually you're trying to do. Don't suddenly show me steps and what. Okay. Okay, this one, your homework, go home and see. Same also, if you understand what to do already. Will be one question from this section, either in test or on exam. Okay, understand? Yeah. Okay, the next one will be sublimation. Sublimation. So if you understand this diagram, I think you've seen this one before. If a sublimation actually is skip the step of liquid state straight away from solid into gas. The good example is dry ice. Dry ice experience sublimation. Okay, we have covered evaporation, condensation. We have covered melting and freezing. So condensation, evaporation. This one also, you should know which one is endo, which one is exo, what happened to the delta H. Okay, so condensation, evaporation, this one deal with delta H VAP. Yeah? Okay. Vaporization, and this one deal with delta H fusion. Okay, here got one delta H, here got one delta H. Then here also got one delta H sublimation. Another process from gas directly to dry ice or directly to solid states is called deposition. Okay, deposition happen in a very, very cold winter where you can freeze the air. You can directly freeze the air if it's very, very cold. Right. Okay, so how you explain sublimation? Sublimation is the change of state from solid directly to gas states. Yeah, sublimation. Sublimation. Okay, so you need to elaborate a little bit on the molecular dimension. What happened to the surface? Molecule at the surface. You need to write molecule leave the surface of the solid, right? And they straight away become gas. Dry ice. This is a solid carbon dioxide, which is dry ice. So at only 179 Kelvin, if you convert into Celsius, will be minus something. So the molecule of dry ice enough energy to leave the surface of the dry ice and become gases. So this is a video. Let you see what happened to sublimation. Oops. Oh, this one, see YouTube a bit. So you see, if you put a dry ice, it will boil. You put dry ice direct in the water. you see it start boiling and convert into gases. So like, yeah. Okay, back to our slides. Okay. This one you read lah. Huh? Six. Okay, I think we stop here. We continue next lecture. Next lecture, we go into intermolecular forces. This have one question, I forget, either in your test or final exam. Right? This one will come up, right? Okay, we stop here. See you next week.